Welcome back to the Sleepless Scientist Channel. Tonight, I want to take you on a slow and gentle journey, not across the stars this time, but into something even closer, something we all live inside of, something we can never escape, something so ordinary we hardly notice it, and yet so mysterious that even physics cannot fully explain it. That something is time. We all know what time feels like. We wake up in the morning, we see the clock on the wall, we feel the hours pass while we work, while we wait, while we rest. But ask the question, what is time, really? And suddenly, the answer slips away. It feels obvious until you try to explain it. Then, it becomes slippery, like trying to hold water in your hands. Time feels different depending on how we live it. When you are bored or anxious, the minutes crawl. When you are absorbed in something joyful, the hours vanish. An evening can disappear in the blink of an eye. So, time is not just something measured by clocks. It is something experienced by the mind. And this is where our journey begins tonight. With the strange way humans feel and measure the passing of time, you don't need to remember any details. You don't need to focus too hard. Just let the words drift over you, like seconds flowing into minutes, and minutes into hours. Together, we'll explore time from the inside and the outside, through memory and culture, through biology and physics, through history and imagination. And by the end, we may not have a simple answer, but maybe we will have something better, a deeper appreciation of what it means to live inside time. Think about the last time you were waiting. Maybe you were stuck in traffic. Maybe you were sitting in a doctor's office. Maybe you were standing in line at the grocery store. The seconds seemed to stretch. The minutes felt heavy. Every tick of the clock was louder than the one before. This is the strange thing about time. It does not always move at the same pace in our minds. When we are bored, time slows down. Every moment feels longer than it should. But when we are fully engaged in something we love, time can vanish. A musician playing music, a writer lost in words, a gamer focused on a glowing screen, a runner in perfect rhythm with their breath. Psychologists call this the flow state. It is when you are so absorbed in the present moment that you lose track of everything else. In flow, you stop noticing the minutes. You stop checking the clock. You simply exist inside the activity itself. And when you finally look up, hours may have passed without you realizing. So, time is not just external. It is not only what the sun and the clock tell us. It is also internal, shaped by attention, by boredom, by joy, and by focus. When you wait, time drags. When you flow, time flies. And both of these are equally real. Time is not only a number on a dial, it is a feeling, a shifting landscape inside the human mind. Our emotions also shape how we feel time. Think of moments of fear. A car suddenly swerves in front of you. A glass slips from your hand. You stumble and nearly fall. In those moments, everything seems to slow down. The world stretches out. Details sharpen. Each fraction of a second feels longer than usual. Scientists believe this is not because time itself is slowing, but because your brain is working faster. It is gathering more information, focusing more deeply, recording more details. And when you remember it afterward, your memory holds so much data that it feels like it must have lasted longer. On the other hand, joyful moments often feel fleeting. A long-awaited reunion, a night of laughter with friends, a holiday that seemed to pass too quickly. During happiness, your brain does not cling to every detail. It flows more freely, without grabbing onto each second. And so, when you look back, the time feels shorter than it really was. Memory is deeply tied to our sense of time. When you remember a day filled with new experiences, it feels rich and long in hindsight. Traveling to a new country, meeting new people, trying something for the first time. But when you repeat the same routine over and over, the days blur together. Looking back, they seem shorter. Weeks or even months collapse into a vague memory of sameness. So, emotions and memory bend the way we feel time. Fear stretches it. Joy makes it vanish. Novelty expands it. Routine shrinks it. Time, it seems, is as much about the mind as it is about the ticking of a clock. Time does not feel the same to every person, and it does not feel the same in every culture. In English, we often imagine time as a line. The past is behind us. The future is ahead. We move forward, step by step, like travelers on a road. But not all languages describe time this way. In Aymara, a language of South America, the past is said to be in front of you, and the future behind. Because the past is visible, something you can see clearly, and the future is hidden, unknown, and out of sight. In Mandarin Chinese, time can be spoken of vertically. The past is above, the future is below. Moments fall downward, like drops of water slipping from the sky. Even within the same culture, our sense of time shifts. Some societies live by the clock, counting minutes, scheduling every hour. Others live by events, letting time flow until the right moment arrives. For some, being late is a failure. For others, it is simply life unfolding at its own pace. These differences shape how we experience the world. If you grow up thinking of time as a road, you may feel pressure to move quickly, to stay on track, to measure progress by how far you've come. If you grow up seeing time as a cycle, you may focus less on rushing forward and more on patterns, seasons, and returns. Neither is right or wrong. Both are human attempts to make sense of something mysterious. Time is not just physics. It is also story. It is language. It is culture. And the way we imagine time changes the way we live inside it. Time is not only something we imagine, it is also something written into our bodies. Every living thing on Earth carries an internal rhythm, a natural cycle that guides when we wake, when we sleep, when we eat, and when we rest. These are called biological clocks. The most important of them is the circadian rhythm. It runs on a cycle of about 24 hours, mirroring the turning of the Earth. When sunlight enters your eyes in the morning, it sends a signal deep into your brain. That signal resets your body's clock. It tells your cells it is time to be awake. Later, when darkness falls, your brain releases melatonin. Your body temperature drops, your heartbeat slows, and the rhythm guides you into sleep. This cycle is so deeply wired into us that even without clocks, even without daylight, our bodies still keep time. In caves, cut off from the sun, people still fall into patterns of waking and sleeping that hover close to 24 hours. And it is not only humans. Flowers open and close with the Sunday. Birds migrate with the seasons. Even the tiniest bacteria follow internal cycles. All of life on Earth is synchronized to the turning planet. Our heartbeat of time is the same as the world's rotation. But biological clocks do more than just track day and night. They also shape how we feel time passing. When your circadian rhythm is steady, time feels natural, balanced, smooth. When it is disrupted by jet lag, by long nights of work, by glowing screens at midnight, time feels distorted. Hours blur together. Days stretch and collapse. So, even without a watch on your wrist, your body always knows the time. It listens to the sun, the darkness, and the rhythms of life itself. Humans have always searched for ways to measure time. Long before mechanical clocks, we looked to the sky. The rising and setting of the sun gave us the rhythm of days. The phases of the moon marked the passing of months. The cycle of seasons shaped the calendar of years. The earliest tools of time were shadows. Sundials used a stick or stone to mark how the sun moved across the sky. The length and angle of the shadow told people what part of the day it was, but sundials only worked when the sky was clear. So people built other tools. Water clocks measured time by the steady drip of water from one vessel into another. Some used sand instead, creating the hourglass. Each grain falling, each moment slipping quietly away. As civilizations grew, so did their need for more precise calendars. The Egyptians tracked the flooding of the Nile. The Mayans created complex calendars to predict seasons and sacred rituals. Farmers everywhere relied on the heavens to know when to plant and when to harvest. Timekeeping was never just practical. It was also spiritual. For many cultures, Time was a gift from the gods, a rhythm woven into the universe itself. Every sundial, every water clock, every calendar scratched into stone was a way of making sense of the great mystery of passing time. And slowly, across centuries, these tools grew more refined, until one day we began to build machines that could tick with steady precision, independent of the sun or the stars. The invention of mechanical clocks was a turning point in human history. No longer did we need the sun, the moon, or the steady drip of water to tell us the time. Now we had machines, gears turning, weights falling, wheels moving with measured rhythm. Early mechanical clocks were large, and often built inside church towers. Their bells rang across towns to mark the hours of prayer and work. For the first time, time itself became public, shared by an entire community. But these clocks were not perfect. They drifted. They lost minutes. They gained minutes. People still relied on the heavens to correct their errors. Then, in the 17th century, a great leap forward arrived. The pendulum. The Dutch scientist Christiaan Huygens discovered that a swinging pendulum kept almost perfect rhythm. Each swing took the same amount of time, no matter how wide or narrow. When he built the first pendulum clock, it was far more accurate than anything the world had ever known. With pendulums, timekeeping entered a new era. Clocks no longer measured just hours, but minutes, and even seconds. Life began to change. Work could be divided more precisely. Ships could keep more reliable schedules. Daily routines grew sharper, more organized, more controlled by the steady tick of machines. And with every improvement, time seemed less like a mystery and more like something we could command. Yet even as our clocks grew better, the deeper question remained. Were we truly measuring time itself, or only building tools to keep pace with its passing? As human journeys stretched farther across the seas, the need for precise time grew greater than ever. On land, clocks guided daily life. But on the ocean, time meant survival. For sailors, knowing the exact time was the key to finding their position on the vast waters. Latitude could be measured from the stars, but longitude, east or west, depended on comparing the local time to the time back at home port. Without precision, ships became lost. Voyages stretched on for weeks longer than planned. Some ended in disaster. In the 18th century, this challenge became known as the longitude problem. The world needed a clock so accurate, so steady, that it could keep perfect time, even on a rocking ship, in storms, in salt air, in changing climates. Many great minds failed, but one man, a carpenter turned clockmaker named John Harrison, found the answer. He spent his life building marine chronometers, clocks with gears so carefully crafted that they resisted the motion of the sea, clocks that stayed precise. Through heat and cold, through endless months of travel. His fourth design, Fier, was small, portable, and astonishingly accurate. It could keep time at sea to within seconds, over the course of weeks. With it, sailors could finally chart their position with confidence. Oceans shrank, trade flourished, empires expanded, all because humanity learned to measure time with precision in the heart of uncertainty. The marine chronometer was more than a tool. It was proof that mastering time could change the fate of nations, and it was only the beginning. As human journeys stretched farther across the seas, the need for precise time grew greater than ever. On land, clocks guided daily life, but on the ocean, time meant survival. For sailors, knowing the exact time was the key to finding their position on the vast waters. Latitude could be measured from the stars, but longitude, east or west, depended on comparing the local time to the time back at home port. Without precision, ships became lost. Voyages stretched on for weeks longer than planned. Some ended in disaster. In the 18th century, this challenge became known as the longitude problem. The world needed a clock so accurate, so steady, that it could keep perfect time, even on a rocking ship, in storms, in salt air, in changing climates. Many great minds failed, but one man, A carpenter turned clockmaker named John Harrison found the answer. He spent his life building marine chronometers, clocks with gears so carefully crafted that they resisted the motion of the sea, clocks that stayed precise. Through heat and cold, through endless months of travel. His fourth design, Fier, was small, portable, and astonishingly accurate. It could keep time at sea to within seconds, over the course of weeks. With it, sailors could finally chart their position with confidence. Oceans shrank, trade flourished, empires expanded, all because humanity learned to measure time with precision in the heart of uncertainty. The marine chronometer was more than a tool. It was proof that mastering time could change the fate of nations, and it was only the beginning. As technology advanced, humanity searched for even greater accuracy. Mechanical clocks, even the finest chronometers, still drifted by seconds over time, and for science, navigation, and communication, seconds mattered. In the 20th century, a new way of measuring time emerged: quartz. When electricity passes through a quartz crystal, the crystal vibrates at a steady frequency. Each vibration is identical, reliable, and predictable. Quartz clocks became far more precise than any pendulum. Small enough to fit in homes and workplaces, cheap enough for everyone to use, they quickly spread across the world. But science demanded even more. So researchers looked deeper, beyond crystals, into the atoms themselves. Every atom has natural vibrations, tiny quantum oscillations that never change. Cesium atoms, for example, vibrate at exactly the same rate, no matter where they are or when they are measured. In 1967, scientists redefined the second based on these vibrations. 1 second became the time it takes for a cesium atom to oscillate 9,192,631,770 times. This was the birth of the atomic clock. Atomic clocks are so precise that they would lose less than a second over millions of years. They guide satellites. They synchronize the internet. They allow GPS to pinpoint your location anywhere on Earth. With atomic time, the world runs in perfect rhythm. And yet, for all our precision, the mystery remains. We can measure time with breathtaking accuracy. But what exactly are we measuring? We all know that time seems to flow in one direction. The past lies behind us. The future lies ahead. We remember what has already happened, but never what is still to come. This is called the arrow of time. But physics equations, whether Newton's or Einstein's, do not care about direction. They work the same if you play them forward or backward. A ball rolling down a hill, a planet circling a star, a photon of light racing through space. The math works both ways. So why, in our experience, does time always move forward? The answer lies in entropy. Entropy is a measure of disorder. A system with low entropy is ordered like a neat row of dominoes. A system with high entropy is chaotic, like those dominoes scattered on the floor. The laws of thermodynamics tell us that entropy always increases. Eggs break. They do not unbreak. Ice melts. It does not reassemble into a cube. Memories form in one direction only. The universe itself began in a state of low entropy, incredibly ordered. Since then, entropy has grown higher and higher. Stars burn their fuel. Galaxies drift apart. Heat spreads more evenly. The cosmos becomes more disordered with time. And so the arrow of time points forward, from order into disorder, from low entropy into high. This is why we age. Why we remember yesterday. Why we can never return to the past. Entropy gives time its direction. But even this does not answer the deepest question. Why did the universe begin in such a strange, ordered state, ready for entropy to increase? No one knows. It remains one of the great mysteries of science. What we do know is that entropy ensures our experience of time has a flow, and once we sense that flow, we cannot escape it. We all know that time seems to flow in one direction. The past lies behind us. The future lies ahead. We remember what has already happened, but never what is still to come. This is called the arrow of time. But physics equations, whether Newton's or Einstein's, do not care about direction. They work the same if you play them forward or backward. A ball rolling down a hill, a planet circling a star, a photon of light racing through space. The math works both ways. So why, in our experience, does time always move forward? The answer lies in entropy. Entropy is a measure of disorder. A system with low entropy is ordered like a neat row of dominoes. A system with high entropy is chaotic, like those dominoes scattered on the floor. The laws of thermodynamics tell us that entropy always increases. Eggs break. They do not unbreak. Ice melts. It does not reassemble into a cube. Memories form in one direction only. The universe itself began in a state of low entropy, incredibly ordered. Since then, entropy has grown higher and higher. Stars burn their fuel. Galaxies drift apart. Heat spreads more evenly. The cosmos becomes more disordered with time. And so the arrow of time points forward from order into disorder, from low entropy into high. This is why we age, why we remember yesterday, why we can never return to the past. Entropy gives time its direction, but even this does not answer the deepest question. Why did the universe begin in such a strange, ordered state, ready for entropy to increase? No one knows. It remains one of the great mysteries of science. What we do know is that entropy ensures our experience of time has a flow, and once we sense that flow, we cannot escape it. At the smallest scales of reality, time becomes even stranger. In the world of quantum mechanics, the particles do not behave like tiny balls of matter. They act like waves of probability. They exist in many possible states at once, until they are observed. In this realm, the familiar flow of time begins to dissolve. Some physicists suggest that at the quantum level, the equations that describe the universe do not actually contain time at all. They describe relationships between events without needing a ticking clock. To us, time feels essential, but perhaps it is not fundamental. Perhaps it emerges only when countless quantum events are added together to form the world we live in. Imagine a movie made of still frames. Individually, the frames are frozen, but when played in sequence, they create the illusion of motion. Time may be like that, not basic, but a pattern that arises from something deeper. This idea is still debated. Some scientists argue time is an illusion created by consciousness. Others believe time is real, but more flexible and complex than our minds can grasp. Quantum mechanics reminds us that the universe is not built to satisfy human intuition. What feels natural to us may not be natural to reality. If time is not fundamental, then our experience of past, present, and future may be just one way of seeing the world, a useful map, but not the full territory. And yet, even if time is an illusion, it is one we cannot escape. We live it, we feel it, we measure our lives by it. Whether or not it exists at the deepest level, time shapes every moment of our human story. We began tonight with a simple question. What is time, really? We have seen how time feels different. When we wait, when we fear, when we laugh, and when we remember. We have seen how cultures imagine time as a road, a cycle, or a falling stream. We have seen how our bodies carry rhythms, how clocks grew from sundials to atoms, and how physics reshaped our ideas. Newton gave us absolute time, steady and universal. Einstein showed us relativity, where time bends with motion and gravity. Entropy gave us the arrow of time, pointing forward into disorder. Quantum mechanics whispered that time may not be fundamental at all. So does time exist? The honest answer is that we do not know. Time may be a real part of the universe. It may be a convenient illusion, woven by our minds. It may be both at once, real at one level, and emergent at another. But even without certainty, we know this. Time gives shape to our lives. It carries us from birth to death, from memory into mystery, from one heartbeat to the next. When you look at a clock, you see numbers changing, but what you really see is your life unfolding. When you close your eyes at night, you feel time passing, in the rhythm of your breath, in the slowing of your thoughts, in the quiet drift of minutes into dreams. And when you wonder what time is, you join a question, as old as humanity itself. Perhaps the answer is not meant to be final. Perhaps the beauty lies in the asking. So rest now. Let time flow gently around you. The seconds will keep moving. The universe will keep unfolding. And you are here, a small and precious part of it all. Good night, and thank you for joining me on the Sleepless Scientist Channel.